Alright, so far the intermezzo on game theory. So now we're back to GANs, and this is our objective function. So we do gradient ascent for the discriminator and gradient descent for the generator. This formula, however, is only for one x and one z. So 1 point here, 1 point there. In reality, we have many points. And to bring this formula to the situation where you have many points, you need to take the expected value. So we need to take the expected value with respect to x here and with respect to z there. Alright? So the final formula is this one, but still there's an issue. And this is the issue. Yeah? So we know that when we try to minimize, we want to go here, we want to go towards the 1, but in the beginning you're going to be around this point 0. And the big issue is that your gradient is going to be quite flat. Yeah, if you look at the gradient, it's going to be quite flat. So the gradient is flat. And that's of course not very good for your algorithm. So instead of minimizing the chance that your discriminator will be right, you're going to maximize the chance that your discriminator will have it wrong. Alright? So this becomes then the max over the expected value over z, and then we take the log of dgz, yeah, and we maximize over 5, yeah. Alright, so that is the little trick that we can apply to avoid this issue. And this function here, you will have something like this, right? So you will have a decent gradient to work from. Alright, so we have our objective function, and we change this to maximize for the issue of the flat gradient. So the next thing to do is we're gonna train our GANs. Now training GANs is quite complex. There's lots of issues. This one trains faster than this one, and so on. Yeah. Usually, I mentioned that a two-player mini-max game always has a solution. Well, Convergence is quite tough here. And there's still a lot of research going on the architecture, what architecture to use for discriminator, what architecture to use for generator. And so there's still lots of opportunities to contribute here. But the training, we will use a mini batch, and then we will alternate between discriminator and generator. So we take one step, and one is actually a hyperparameter, k. If you look at the paper of Goodfellow, they suggest to take k equal to 1. So then we sample from here, and we sample from here, and we update the discriminator. So this is training the discriminator, and we will use gradient ascent because it's maximized, right? And then the same thing, you're gonna sample again from z, and you're gonna train the generator. And here again, gradient ascent according to this function. And this you will repeat. Yeah, and we will do a coding exercise on it, and it will become quite clear how to do.